First of all, if we're going to solve quadratic equations, we have to know what quadratic equations are. So what are these quadratic equations that we're going to solve? What makes them quadratic? X squared will be the highest power of x. Now, if x is squared, if it's a quadratic equation, we have learned two ways to solve these quadratic equations. Do you know what the two ways are that we have learned to solve a quadratic equation? Don't everyone answer at once. The two ways that you can solve a quadratic equation that we have learned so far is factoring and the quadratic formula. Did you hear me say so far? There are some other ways that we are going to learn to solve quadratic equations, but those are the two that we have learned so far. When you get to the quadratic formula, sometimes you have to simplify a radical in order to solve the quadratic formula. And so we need to go back and look at a few more radicals. So, as I told you when we went through this lesson the other day, it was almost the same lesson. This is not how I teach simplifying radicals. The way that I teach simplifying radicals is called the birthday cake. Now, that's just a nickname. The actual mathematical name for it is prime factors. So, don't go over there in the pre-cal class and tell Miss Finnan you're doing a birthday cake. Tell her you're doing prime factors and she'll know what you're talking about. And yesterday we had a lesson about this number called I. What is I equal to? I is equal to the square root of -1. That is its definition. Now, what is I squared equal to? -1 without the square root, because if you square it, the square and the square root cancel each other out. And what do you remember about I squared? Never, never, never leave an I squared in an answer to a problem. You always change an I squared to a -1, and then that usually means you're going to keep on simplifying. Now, I really don't think you need quite this many examples, so we are going to start with example number 2. Do you see that it has a negative under the radical sign? So this is equal to, isn't that true that -81 would be equal to 81 times a -1? There is a property of square roots that says if you have numbers multiplied together, you can separate them under separate square roots. Now, what is the square root of 81? And what is the square root of -1? Now, supposing, though, that you didn't notice that 81 was the perfect square, could you go ahead and do a birthday cake on that? And some of you did that on the homework paper the other day. So you're going to put the 81 down here at the bottom, and is 2 going to divide into it? 2 goes into 81? No, I don't think so. Does 3 go into 81? How many times? And does 3 go into 27? And does 3 go into 9? And does 3 go into 3? And why do you do the birthday cake anyway? To find pairs. So there's a pair of 3s and another pair of 3s, and what's left over? A 1. Well, what's 3 times 3? And what is the square root of 1? 1 is actually a perfect square number. What is the square root of 1? Do not tell me that the answer is 9 square roots of 1 because 1 is a perfect square number. That is the same as saying 9 times 1. What's that equal to? The 9 that we already came up with, and that was for the 81. And then where did the I come from? From the minus sign, the negative sign, I should say. Would you please look at problem number 4? This is equal to 72 times the square root of negative 1. The 72, I believe, is not a prime number, so I am going to do the birthday cake on that. How many times does 2 go into 72? What? 36. And how many times does 2 go into 36? And then 2 goes into 18. Does 2 go into 9? But 3 goes into 9. And most of you seem like you were pretty good doing that. The only mistake I saw occasionally is people starting with a number that was not 2 or 3. The reason you start with 2 or 3 instead of something like 6 or 10 is because if you don't start with 2 or 3, you might miss one of your pairs. And so there's a pair of 2s and there's a pair of 3s. So we have a pair of 2s and we have a pair of 3s, and what's left over? And 1 times 2 is 2. And I skipped a space here because there's something else we haven't done yet. What is this equal to? And that's usually, this is the order we usually write it in. 6i square roots of 2. Whole number, I, radical sign. That would be the order that we would write it in. That's just the traditional order. Just like the problems we did previously, this is problem 6. If there's a number out in front, we just leave it there out in front. We'll get back to it in a minute. And so we take our number 24 and we write it down here. 2 will go into 24 12 times. And 2 will go into 12, and 2 will go into 6, but 2 won't go into 3. The reason we do the birthday cake, whose real name is prime factoring, is to find the pairs. So we have a pair of 2s, and what's left over? This 2 and this 3 are left over. We also had a 4 out in front. Now, all of this prime factorization is a property of multiplication. And so these are multiplied together. This would be 8 on the outside and 6 on the inside. And there's not an I with this one. Why isn't there an I on this one? When this is positive, you will not have an I in the answer. When the radical is negative under the radical sign, that's when you get the I in the answer, because that's when you get the square root of negative 1, which is the definition of I. Got that clear? What? Question on that? A few of you had some issues on the test, in particular with the variable type problems. You knew how to do the birthday cake, but you got confused if there was a variable. Well, all you do is expand the variable. 1, 2, 3, 4, 5, 6. That is what x to the 6th power means. Correct? 1, 2, 3. You do the same thing. You find the pairs because the square root sign asks you, what's a pair? Well, how many pairs do I have? So that becomes x to the 3rd power. Is there anything left over that doesn't have a pair? So if there's nothing left over that doesn't have a pair, I don't have a square root sign in the answer because everything paired up. Okay, let's tackle this ugly one. The first thing we're going to look at is the 40. 2 will go into 40. 2 will go into 20. 2 will go into 10. 2 will not go into 5. The only thing that divides 5 is 5. We do the prime factoring to find the pairs. So, the 40, not the negative sign, we haven't done the negative sign yet. The 40 becomes a pair of 2s, and I have a 2 left over and a 5 left over. I'm going to move this 2 over because I'm going to need some more space here. And so this is the 2 that represents the pair. This 2 comes down in front. What does this negative sign do? That negative sign would be the same as negative 1 times 40. So that negative sign causes an I to be in the answer. Then we have x squared y to the 3rd power. There's a pair and there's a pair. Here's a pair of x's and there's a pair of y's. And what's left over with our variables? Okay, so we have to get the final answer. We just have to clean this up a little bit. This would be 4. Guess we would usually write that x, y, and then the I, and 10y. That's an ugly answer, but it's not that hard to come up with, is it? Do you feel like that's enough examples, or do you need a few more?